For any triangle ABC, show that the following is true. Let us begin. So here, we'll start with the first expression, s minus a multiplied to tangent of a over 2. Now clearly here, there are a few terminologies that have been used here. Here, s represents the semi-perimeter of a triangle. So, s is going to be given by a plus b plus c divided by 2. So we take the perimeter, take its half, that's going to give us the semi-perimeter S of the triangle ABC. Now here, A, B and C, these letters in the lower case represent the sides of the triangle ABC, and A is going to be opposite to that of angle A, B is going to be opposite to that of angle B, and C is going to be opposite to that of angle C. Okay, and we also have standard half angle formulas for each of tangent of A over 2, tangent of B over 2 and tangent of C over 2. So here I've specified all the three formulas. So let's use the where S represents A plus B plus C over 2. So that means now we have S minus A multiplied to tangent of A over 2. So this will be the square root of S minus B multiplied to S minus C whole divided by S times S minus A. Fine. Now what we'll do, we'll take this S minus A inside the square root. All we have to do is take its square to make it a perfect square. So that means we have S minus A whole squared times S minus B times S minus C divided by S multiplied to S minus A. So here we can factor out one S minus A from the numerator and the denominator. And we are also going to multiply one S to the numerator and one S to the denominator. Now, the reason why we've done this, because now what we have in the numerator is the expression square root of the semi-perimeter S multiplied to S minus A times S minus B times S minus C. Now, this is nothing but the area of the triangle ABC. This is also referred to as the Heron's formula. So according to the Heron's formula, we have the area of the triangle ABC in the numerator. So that means this entire expression in the numerator can be replaced with delta. This will be divided by the square root of S squared. Square root of S squared will be simply S. Now that means we have said here that S minus A times tangent of A over 2, this is equivalent to the area of the triangle divided by the semi-perimeter S. Now we will show that this same expression also holds true for S minus B times tangent of B over 2 and S minus C times tangent of C over 2. So let's start with S minus B, also S minus B times tangent of B over 2. So that's going to be equals to S minus B multiplied to the square root of, so tangent of B over 2, that's going to be S minus A multiplied to S minus C divided by S times S minus B. We can rewrite it as, we will have the square root of S multiplied to S minus A times S minus B times S minus C divided by S squared, which is going to give us delta over S. Similarly, we'll leave the third one as an exercise for you to try out. So similarly, we can show that S minus C multiplied to tangent of C over 2, this will be equivalent to delta over S. So here we have successfully showed that hence in any triangle ABC, S minus A times tangent of A over 2, this is going to be exactly the same as S minus B times tangent of B over 2 equals to S minus C times tangent of C over 2. And all the three expression is given by the area of the triangle divided by the semi-perimeter S. Hence proved.